This is 2020 paper 2, question 1. So a restaurant is offering a 3-course meal consisting of 1 starter, 1 main course and 1 dessert. There are 4 different starters to choose from, 6 main courses, 8 different desserts to choose from. So how many different 3-course meal combinations are available? So this is the fundamental principle of counting. So what you need to do is you need to multiply the choices you have for the starter by the choice you have for the main and how many choices you have for dessert, and multiply 4 by 6 by 8, get 192. So there's 192 different options that they can choose from. When Jack visits the restaurant, he discovers that the restaurant still has the 4 starters and 6 main courses available, but is sold out of some of the desserts. Jack now has 120 different 3-course meal combinations to choose from. How many desserts are still available to Jack? So there's still 4 starters, still 6 main. We don't know how many desserts there are, and it gives you 120 options. So what we can do then is multiply 4 by 6 by something gives you 120. So 4 by 6 is 24. So 24 times x gives you 120. So if you want to find what x is, just divide 120 by 24 and you get 5. So that means that there's 5 desserts to choose from. So there is 3 less desserts then. For part B then, you have in a large population, 1 in 8 of the people play tennis. 4 people are chosen at random from the population. What is the probability that the 4th person chosen is the only one to play tennis? So you know that 1 in 8 play tennis. So that means that 7/8 don't, because these two should add up to 1, so the difference between 1 and 8 then is 7, so that's why 7/8 don't. So you've got 4 people chosen, so the probability, and the 4th person chosen is the only one to play tennis. That means that this first person doesn't, the 2nd person doesn't, the 3rd doesn't play tennis, but the 4th one finally does. So it's not and not and not and does. So we're going to fill in the probabilities for doesn't. So that's 7/8. Probability of the one who doesn't, which is 7/8 again. The 3rd person doesn't play tennis still, but the last one does. So because there's 4 different people, you have to multiply them together because it's the 1st and 2nd and 3rd and 4th person. So when we multiply that together, we get 343 over 4096. And I would just leave it as a fraction like that if it cannot be simplified any further. Part 2 then, 3 people are chosen at random from the population. What is the probability that exactly 2 of them play tennis? So that means that we have different options to choose from. So we can have a person who doesn't play, and then 2 who do. You can have a person who does play, and then 1 who doesn't. Or you can have 1 who does, then 1 who doesn't, and 1 who does. Okay, so I'm just going to fill in the probabilities for each one. So that's doesn't is 7/8, does is 1/8. I multiply them together, so that's 7 out of 512. So that's my first option. The second option is that they do, and then the last person doesn't. So same probability here of 7 over 512. And then you can have a probability of a person who does, 1 who doesn't, and 1 who does, which is also 7 over 512. So what we need to do then is we need to add these 3 fractions together, and that gives us a total of 21 over 512. And that cannot be simplified any further.